Right? Let us study the concepts called binary search trees. So for binary search trees, uh, before we study the binary search tree, let us study the uh, abstract data type of the dictionary. Because what dictionary indicates, dictionary always it is a collection of pairs such as key, comma, item. So whenever you are searching for the dictionary, you will be always having two items. One specified key will be given to you and the corresponding item will be given to you for searching. Corresponding item will be given to you for searching. Right? So where the first component of the pair is key and the second component is the item. It is just a pair of key comma item which represent associated information with the respective key. So key is there, corresponding item is there. So we assume that no two pairs have the same key. So when you look at the dictionary usually in your day-to-day life, no two words will be repeated in the dictionary. So every word is different and it is having its own independent meaning. It's having its own independent meaning. So same way we are assuming that there are no duplicate keys. There are no duplicate keys and the corresponding items. So the dictionary with the help of phone numbers, so the dictionary with telephone numbers and names. Say for example, this is what is the telephone number for which we are assuming it as the key, and this is what is the name, corresponding name. So this is what is the key value and this is what is the corresponding name. For this key, this is the name. Here number is the key and name is the actual item which we want. Name is the actual item which we want. So let us say the ADT dictionary. The ADT dictionary is the one that shows the various operations and specifications of a dictionary. So what basically we are just creating and checking. So these things are repeated here. Actually, see here, it is repeated here. So ignore these two lines. We are studying it later. And ADT dictionary is the one which shows different operations. So for every data type which we study, we should have the objects first and then the functions. Objects and then the functions. So what objects indicates here? A collection of n pairs where each pair has a key and associated item. So n pairs we are going to assume them as objects. And functions for all D which belong to dictionary. D is our dictionary. Item, key, n, they are nothing but the integers. They belong to integers. So with these entities, we are going to define different functions. So when you are talking about abstract data type, it will be having three types. We will be writing two columns. So return type, which actual type it is returning, what is the name of the function and how actually it is implemented. So first create function, because when we have the data structure, then only we can perform different operations on that data structure. So first create an empty dictionary and its return type is empty dictionary. So second one is empty. Check whether the dictionary is empty. When dictionary will be empty, if n is equal to 0. So when n will be 0, when there are no keys and when there are no elements in the dictionary will be empty. Then simply we are going to return true. What true indicates? Dictionary is empty. And what false indicates? Dictionary is not empty, there are some elements in the dictionary. Insert the item with key into D. That means it is an insert function which is invoked for inserting an item with the specified key into the dictionary D. What it does? Insert the item with the key into dictionary D. Insert the item with key into dictionary D. So insert this item with key into dictionary D. So let us delete. Let us write the definition of the delete function. I want to delete one item from the dictionary D with this key. So before you delete, it must be present. So if the key is present in the dictionary D, then delete that particular entry. Search. We are trying to search for an item. We are trying to search for an item. So search in the dictionary D with the specified key item. If key is present in dictionary, return the corresponding item, else return 0. So that's it. So this is fundamental prototype which is required for studying the binary search trees.